Hello and welcome back to Apt for You. In this particular video, I'll be discussing a new problem from trees, and basically it is on traversal of the binary tree, and the traversal is boundary traversal, right? So I hope you have already gone through this particular problem statement and you have understood what the problem actually says. So in this particular video, I'll be focusing on explaining how to approach this particular problem. So let me just give you an overview of the problem statement. So this particular problem is basically on boundary traversal, right? So the problem has asked basically to perform a boundary traversal. Now according to this problem, according to this definition, we basically have to perform a given we are provided with a binary tree and we have to perform the boundary traversal. Now they have said that the boundary traversal basically consists of three things. What are the three things? The very first thing that it has is basically left boundary. So you have to print the left boundary first, then you have to print the leaf nodes, and then you have to print the right boundary nodes, but in reverse order, right? So remember, we are interested in performing the boundary traversal. The very first thing, we have to perform the boundary traversal. Now if you ask me how to perform boundary traversal, I will say you that in order to perform boundary traversal, first of all you should try to print all the boundaries on the left. So print the left boundary. So first I will print the left boundary, then print the leaf nodes, and then print the right boundary but from reverse order. Done. Okay, so what does it look like? So basically if you look into this particular example, we have these nodes, right? This is a tree and we have these as nodes. So if I talk about the left boundary of this tree, so if I talk about the boundary traversal, of this tree, what are the steps that we have to do? The very first thing that we need to do is print the left boundary. Second thing that we have to do is basically print the leaf nodes. The third thing that we have to do is basically print the right boundary, right? So you can clearly see that this particular problem is made of three problems, right? So it comprises of three problems. What are the problems? Left boundary, leaf nodes, right boundary. Now let us understand what is a left boundary actually. So left boundary means, if this is the root node, see what are the elements on the left? 28, 4. Okay, are there any more elements on the left? No. So if you just talk about the left boundary, so left boundary basically means you start from the root node and try to go as much as left as possible. Remember, you only have to start from the root node and try to go as much left as possible. So from here I can go to 8, from 8 I can go to 4, from 4 I can go to nowhere because it is null. Then you will check whether there is any element to the right of this point, because from here I cannot go further, but there might be some cases where this tree can take this direction, which indicates that suppose there might be some cases wherein, so I'm explaining you, there might be some cases where you have 20, then you have 8, suppose this is the right subtree. So 28, you have 4. Now you don't have any elements to the left of 4, but you have an element to the right of 4, like suppose 6, and then from 6 you have more elements, 10, 11 and so on. So don't you think that this will be a part of the left boundary? Definitely yes, because I am trying to go as much left as possible, right? I am trying to go as much as left as possible. That is why I am giving preference to the left subtree first, and then if you find out that there is no more path to the left, then you just take a right and then start going left as possible. This is also a valid thing, isn't it? So this is also a left boundary, 6, 10 and 11 here. Okay, so remember why I am explaining you, because we are going to deal with this condition. There might be situation that you are taking as much left as possible, it's fine, but you will find out that you will end up with null. But if you have some more elements to the right of this, like 4, 6 and then you have 10 and 11, then definitely these nodes will be the part of the left boundary. So you have to consider them as the left boundary. Remember, you have to consider these nodes also as left boundary. Got the point? Fine. So why I am explaining you this? Because we have to design our code such that these nodes will also be considered to be the part of left boundary. Done. Now considering the right boundary, so right boundary also we have somewhat a similar logic. Stand on the root node and try to go as much right as possible. So you are standing on the root node and trying to go as much right as possible. All these nodes are basically our right boundary. Now do you think if I take the right of this, I have nothing but null? Okay, it's fine. So it indicates that in this particular figure I have only 20, 22 and 25 as the right boundary nodes. But there might be certain conditions when we have 20 followed by 22, and suppose it has left subtree in the left. So 20 followed by 22 I have 25, and now you don't have anything on the right, but you have one element in the left followed by a series of element in the right of it. So now if I tell you what is the right boundary of this, so you will say 20, 11, 25, it's fine, and from 25 you cannot go further right. So you say that I will stop here only because this is my boundary. No, remember this, if you can't go further right, take left and see if there is a node. If there is a node, jump to that node, and now from here you can start going right. So basically these nodes will also be the part of my right boundary. Remember? Fine. Why I am explaining you? The same reason, because this is important while writing the code. So I hope you understood the definition of the left boundary and the right boundary, and the middle thing is the leaf nodes, and obviously there is no doubt with it. Leaf nodes are these elements which do not have any left child and the right child. Done. Point to be noted, this is a part of the leaf node as well as the left boundary. So we don't have, remember, we don't have to print it twice, print it only once. This node is a part of the right boundary as well as the leaf node. So remember, we don't have to print it twice, we have to print it once. Okay, so we shall be handling these cases, don't worry. So for the time being, let us quickly write our example here. So we basically have a tree with node 20, and we have 8, we have 22, we have 4, we have 12, right of it is 25, and 12's left is 10, 12's right is 14. So this is our tree that is given. Now quickly let us start solving this particular problem. So before I start doing anything, let us first of all understand the problem statement. So here you can see we have to basically complete this function print boundary, because this print boundary function will be called receiving a root node as the input, and it will return a vector of integers which will basically store the traversals. Fine. So as always, since I have to return a vector of integer, so I'll better declare a vector of integer output. Fine. This is what we generally do, right? So we will declare a vector of integer output first. Now after I declare a vector of integer output, what will I do? I'll first of all come inside, I'll say output dot clear. I'm flushing any values if any, and then I'm making it ready for receiving the output sequence. And right now, okay, so remember, right now I'm inside this function print boundary, and I know that I have to do the boundary traversals. So you know that for doing the boundary traversal, we are going to do three things. The very first thing that I'm going to do is print the left boundary, then print the leaf nodes, and finally print the right boundary, which clearly indicates I will be designing three functions, one for printing the left boundary, one for printing the leaf node, one for printing the right boundary. So without delay, let me say get left. I'll pass the, let us say what I'll pass, I'll explain you later. So get left will be one function to print the left boundary, then get leaves will be the function to basically print the leaf nodes, and then get right will be a function to print what? To print the right boundary. Done. Now remember, right now I have declared my output vector, so my output vector is ready here. Output vector is ready. So we know that while doing the boundary traversal, the root node will always be printed first, right? The root node here, this 20, this root node will always be printed first. So why not do one thing? The very starting, before doing anything, just push, after creating this particular vector output and doing output.clear, you can directly push output.push root data, because we know that this will definitely be inside the sequence. So I am just pushing this 20 here. Done. Now we are interested in finding what? Get left. Get left means what? Left boundary. So left boundary will present where? In the left subtree. I hope you are getting the point. The left boundary will be a part of the left subtree. So basically it will be a good idea to pass the address of the left subtree. That is why I am saying here get left, root left. Done. Clear. Similarly, the right boundary will be a part of the right subtree. So basically we can directly say get right, root right. Done. What about the leaf nodes? Now remember, this is another problem, a separate problem in itself, where we have, suppose if there is a problem that given a tree you have to print the leaf nodes. So let me just explain you the approach right now. Given a tree, you have to print its leaf nodes. How do you print it? So we know that we can do this recursively. How? We will first of all pass the address to the root node, right? So I'm just explaining you this get left function. How do we write the get left function? Now get left function, basically suppose we have a tree and we have to print all the leaf nodes in this tree. So I will be writing a recursive problem. How? So basically you will consider the root node first and you will call the function left subtree. And after left subtree execution is complete, then you will call the function on the right subtree. What is the function? Get leaves. So get leaves, first of all what you are doing is basically trying to go as much left as possible. Once you come in a node which is basically a leaf node, how do you detect that? Basically the left child is null, the right child is null, and if you come across such nodes, basically that will be the part of the leaf node and you will consider it. Okay, now if you consider this node, its left child is not null, right child is not null. So do you think that it is a leaf node? Definitely it is not a leaf node. But if you consider this node, its left is null, right is null. So basically it is a leaf node. So you will consider this node, right? So I shall explain you how do we write the get leaves function. But let us proceed serial wise. Okay. So right now first of thing will be pushing this roots data into the output vector. Done. Now get left root left will be called. So the moment I say get left root left, please quickly recapitulate the logic of the left boundary, right? So I'll be writing the left boundary code. So I'll say void get left, and remember I'll be receiving a root node. So node star root. What do we do? First thing we check is if root is equal to null. Remember, if root is null, what do? We return it, right? But if root is not null, which indicates that if the root if the left subtree is not null, that is it, isn't it? Because right now what you're passing, this node's address, root left is this, you have passed this node's address. So if it is not null, you will check whether its left element is null, not null, root left not equal to null. If its left element is not null, which indicates that it has got some more elements to the left of it. Okay, so what we can do, we can just say output dot push back root data. What will happen by this? So remember, what happens is basically I have received this node as the input. This is not null. If it is null, then return, but it is not null. So I will check if there are any more elements to the left of it. If there are any more elements to the left of it, which indicates I can go further left. I can go further left. That is get left root left, recursive call on the left subtree. Done. But before going left, before going further left, you should basically track this data, isn't it? You should keep track of this data. You should put it in the output vector, because you know the result will basically consist of these left boundary nodes. That is why I am writing output.pushback root data. Right now root is on this, so push it into the vector. Done. So this 8 will be pushed here. Done. And then do the recursive call on the left subtree. Again this goes further left, which means now control comes here. Now this is your root node. Remember, this is your root node now. Now obviously this is not null. If it is null, then return, but it is not null. Now it's not null, right? So what can be another situation? If root left is equal to null, which means, remember I have discussed about one logic, like suppose you have 1, then 2, you don't have any elements to the left of 2, but one element to the right of 2, that is 3, and then you just go like this. This might be a situation, right? You don't have any elements, you started going as much left as possible, but then you find out that there is left element is null. So what will you do? You will take one step right and then doing the left traversal, and then start doing the left traversal. That is why the moment I find out that the root left is equal to null, if it is not equal to null, do this thing. But if I found that the root left is equal to null, I should have a else part for it. Then else if, what should you do? Check whether root right is not equal to null. So if you find out that the left child is null, like in this case, suppose you started from top, you went as left as possible, keeping track of these nodes, and then you find out that its left is null. So what will you do? You will basically start doing the left traversal from the right node, right? So I will say here, else if this, say get left and pass the address of the right node, root right. done. But before passing the address of this, you should basically keep track of this value. You should print it, isn't it? Because this will be the part of my boundary. So I will be just, before doing a recursive call on the right side, I will say output dot pushback, sorry, output dot pushback root data. So what will happen? Remember, here, from here I started moving as much left as possible. Now this is the root node, I went left, it is null, which means I cannot go further left. So in that condition, when your root left is equal to null, then this will be executed. Come inside and check if root right not equal to null. Definitely root right is not equal to null, which means I can go right. So basically include this particular root node, that is this one, into your list, and do a recursive call on this node. Means you will consider this subtree right now and try to print its left boundary. So get left, root right. So this was the root, its right is this. Got the point? So that's all on left boundary. How do you print the right boundary? The logic of the right boundary is also very similar, but before that we will follow the sequence only. So first thing is get left, we did this. Now get leaves. How do we get leaves? So I hope you know how to print the leaf nodes of the tree. So I'll be very quick with this. So void leaf, right? Sorry, void get leaves. So void get leaves, I'll receive the root node, so node star root. And what should you check? First thing that you should check is if root equal to null. So the moment you find out that root is equal to null, you simply return. Otherwise, what do you do? If root is equal to null, you return. Otherwise, if root is not equal to null, then we know that for printing the leaves, now the leaves can be in the left subtree. Leaves are in the left subtree also, in the right subtree also, right? So you consider any tree, just I'm giving you an overview. You consider any tree, okay? So leaves are on the left subtree also, on the right subtree also. So one time I will call this function get leaves on the left subtree and one time on the right subtree, okay? So first I will call on the get leaves excuse me. So get leaves on the left subtree, root left. So what will happen? This way I will just traverse as much left as possible, which means from here, from this node I traverse this node, from this node I traverse this node. Now again you'll try to go left because it is a recursive call. Now left, what will you receive? Null. If you receive null, then it will return, come back. What should you do now? You should basically say if root left is equal to null and root right equal to null. What does it indicate? So if you find out that a node's left child is also null and right child is also null, which indicates it is a leaf node. So this is an indication of what? Leaf node. So what should you do? You should include it into your result. So output dot what? Pushback. What? The roots data. Right? So I hope you got the point. So if you come across, now you first of all you are receiving the root node address, you are trying to go as much left as possible, and the moment you find out that the left child is null, you immediately, what you do, you try to test whether that particular node is a leaf node or not. If it is a leaf node, you immediately insert it into your result. So you can see that will be inserted into the result. Otherwise, what will you do? You will call the function on the left subtree, right subtree. So again I'll say get left, okay, because what will I do? I know that very well, isn't it? Because if we are doing the left, we are doing what? We are doing the leaves traversal. So the get leaves root left is already done. So otherwise we are going to say right subtree, get right, and sorry, get leaves, and we will say root right, isn't it? Because we have printed all the leaves from the left subtree, now we are interested in printing the leaves from the right subtree. That is why get leaves root right. Okay, and before that we are doing get leaves root left first. And what is the condition for checking the leaf node? If root left is equal to null and root right equal to null, then it is a leaf node, right? And we should push it into our result. That is output.push root data. Done. This is how we are going to print all the leaf nodes. Done. Now what we are going to do, basically now we are going to print the right boundaries. So how do we print the right boundaries? Again the same logic remains the same. We basically need to have a function void get right. Okay, it will receive a node as the address, root node. And what should we do? Now remember, first thing that we do is root is equal to null. If root is equal to null, it indicates that if root is equal to null, it indicates you can't do anything, right? Otherwise what? Otherwise we should try to go as much right as possible, right? Isn't it? This is what we do generally. So we check if root right not equal to null. So if root right is not equal to null, try to go as much right as possible. That is why we are saying get right. Again recursive call on root right. Done. And remember, we want to basically consider the data here in the reverse order, means from bottom up approach. So initially I will try to reach to the leaf node, and while returning I will be printing that nodes. Remember, that is what we want, because we don't want to print them in the order like 22 then 25 as per the problem statement given, as per the question given. They have asked us to print this in reverse order, and if they have asked you to print in reverse order, remember in recursion we can print in reverse order by printing the values in the descending phase, isn't it? Means while returning phase, in the backward phase. So here that is what I am going to do. Here you can see if root right not equal to null, means if there are some elements to the right of it, then we just go further right. That is why we are doing a recursive call on the right side, right? There will be definitely be a point where you will stop. That is where root will be equal to null. That time what will happen, you will return here, and then you can basically print the node. So output, that will be here, output dot pushback root data. Done. Now what if you come across a situation like this, as I said, isn't it? You have 20 here, suppose you have 22 here, now you have started coming at 23, 24. So in this case, first of all I started with here, I am trying to find out the right boundary. I moved as much right as possible. Now right of this is basically null. So if I find out that the root right is equal to null, if root right is equal to null, what do we do? Check for root left. That is why I will be checking for root left. Else if root left is not equal to null, so now if root left is not equal to null, what we can do? We can call the get right traversal on this subtree root left, isn't it? So initially remember, what did you do? You started from here, you moved right, you further moved right, but it is null, which means you cannot go further right. So in that case what should you do? We should check if left is not null or not. So definitely left is not null, which means there can be a path from the left side of this. So just move left and again start going, sorry, the diagram should be like this: 22, 23, and then suppose 24, 25, 26. So in this case what will happen? So you moved as much right as possible, but you can see that you cannot go beyond 22 because it is null. So that case you just come to the left, and now you just apply the right traversal function on this subtree, That is what is being done here. Get right root left, done. So get right on root left. So this is the root, this is the left node, and perform the get right traversal on this subtree. Done. And again same case here, while returning means in the backward phase, what you are going to do? Output dot pushback root data. So I hope you are familiar with recursion. That is what is going to happen here. So that's all from the definition of get left, get leaves, get right. So this should definitely work fine, and I think we should now return here the output. So I hope I have not made any mistake. Let us quickly check. Okay, let me just explain you the working. So remember, the very first thing is this function will be called, root node will be received, I will push it into the resultant vector output, and then what will happen is get leaf root left. Root left is nothing but this node, and I'll be just performing a left boundary traversal on this subtree. So as per our function of the left boundary traversal, what will happen? We know we will try to go as much left as possible and print those nodes in the way. So 8 will be printed, then 4 will be printed. And if we find out that okay, there is a child node, then we are not going to do anything inside the get left function. You can see our get left function. This is our get left function, right? So get left function has no provision for child nodes, right? If you have any child node, it is not going to do anything, right? It is just going to go as much left as possible. Okay, and you will find a null should return. Go right, null, return. What next? So nothing. This function is complete. Now get leaves will basically print out my leaf nodes. Get leaves is going to print out my leaf nodes, and that is why I have printed the leaf nodes. What will happen is I'll pass this root node. So it will first of all consider the left subtree and print all the leaves in the left subtree, which is nothing but 4, 10, 14. So 4 is already printed. 4 will not be printed in previously. Okay, this 4 will not be printed previously. This 4 will be printed right now because as I said, get left function has no provision for the leaf nodes. This get leaves function is focusing on the leaf nodes, so this will print it 4, 10, 14 and 25. 4, 10, 14 and 25. Done. What next? Then basically we are going to print what? The right boundary. So right boundary, so basically I'll be starting with this node, root right. Remember, if you focus on our function root right, if you focus on our function get right, so get right function is basically passing the root right. Root right means this is the root, this is the right node. This node address we are passing. So from here you are initially trying to go as much right as possible, and then in the backward phase you are basically, see, you are going as much right as possible first, and then in the backward phase, in the descending phase, basically you are trying to print the values. I am not printing, I am just putting it into the output vector. And I hope you understood why I am using these two conditions, right? I have already explained. So basically what will happen is 25 will be here 22, and that's it, right? So this will be the output, that is 20. Let me write it properly. So the output will be basically 28, 4, and then you will have 10, 14, 25, 22, right? So this was printed by get left. This value was computed by, not this, still this, get leaves, and only this is printed by get right. So okay, so I hope this video is helpful. Now let us just quickly compile, expecting no issues, and I hope you have not made any silly mistake. Okay, so output.push back, it should be push back. So line number 162, 160. So 160 basically it should be push back. Done. 162, 162. Okay, so see here again, 162 basically this particular line here, this line, get leaves, we should pass the root node, isn't it? We are not passing the root node. We are calling the get leaves function, but we are not passing any node. So basically we should pass the address of the root node. So root node. Done. And any more issues? Let us check. So the output is fine for the basic test case. Let us see if it is passes for all the cases. That's it. So I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. And remember, this is how we are trying to write the code, right? So this was all about the boundary traversal. The first thing is to get the left boundary, then we print the leaf nodes, and then we print the right node. So if you focus on this output, this part is basically printed by the left boundary, 20 and 8. 4 to 25 will be printed by the leaf nodes, and this 22 is basically printed by the right boundary, right? So remember, when I say get left, okay, when I said get left, which subtree was passed? This subtree. When I say get right, this subtree was passed, right? And when I said get leaves, the entire tree was passed. right? So that's it from my side. The time complexity of this particular problem was order of n. Okay, this particular problem can be solved in order and time complexity. Space complexity is height of the tree, depends upon the height of the tree, because that is what will be the number of recursive calls. Okay, the number of recursive calls that are being made is depending on the height of the tree. So order of height, sorry, the space complexity is order of height. So that's all from my side. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section, and just like, share and subscribe. Thank you.